let's get back to basics. Before we cover a few problems here, well, a lot of problems, but let me switch over to a whiteboard. And let's start with the basic concepts that we need to make sure that are just, you know, solidly entrenched. And let's start with a circle. Now we're gonna discuss the circle more next week, but remember to start with the circle, we count from the right to the left, and a circle is 360 degrees. Again, basic stuff, but it's worth repeating. A circle, we start at, let's say, this point on the right. We count counterclockwise, and a circle is 360 degrees. So if we start at that point and we stop halfway through, that arc is 180 degrees. And believe it or not, this is going to be the premise of a couple of questions on the test, because that's a straight line. And a straight line is equal to 180 degrees. Okay, good. Now, so far, these two things, they can't fake through a sketch or a diagram on the test. I mean, if they draw a full circle, that's a circle. If they draw a straight line, you can absolutely take that for granted that that's 180 degrees. I think anything else, you cannot trust the sketch is drawn to scale and that it's accurate as it is demonstrated. You have to question anything else that's sketched. Okay, so again, we start from the right-hand side. If we go a fourth of the way, that's 90 degrees. Again, review, I know that. 90 degrees is another, just as the straight line is going to be very helpful to us, 90 degrees is going to be critical in some of the questions we're going to see. I mean, at least 2 or 3 of them. And the important thing to know about that, again, because we know they're going to try and trick us, we know they're going to use trick sketches on the test. They're going to use things that are not drawn to scale, which is important to, again, always question that. Say, is this drawn to scale? Do I know that this is drawn to scale? If not, then I have to assume it's not drawn to scale. And it will be D, you know, in data comparison. I don't know. It could be true. It might not be true. If they don't specifically tell you that something is 90 degrees, even though it may be drawn to be 90 degrees, you have to assume that it's not. And so there are a couple of ways of knowing that for sure. One way is that if they use the right angle symbol, then that is certainly a 90-degree angle. That's not something you have to question. If they give you that symbol, then that means it's drawn to scale. The other, and this is what you're going to see more commonly, is in the question, they may use the perpendicular symbol. And that is just as certain as the right angle symbol. That tells you that these two things are perpendicular, which means they meet at a 90-degree angle. So, you know, that's extremely useful. Then you can, and that's going to come in extremely handy when we use triangles. In order to use several special rules that pertain to triangles, we have to know that something is a right angle. If we don't know that it's a right angle, we can't use any of those special relationships. But if we do know it's a right angle, a right triangle, then we can do all sorts of things. And, you know, it's a lot we can do with triangles. Okay, finally, the next most common measure is to divide 90 by 2 is a 45-degree angle. That's also going to be very helpful. And that you see in real life. That you see every day if you look around you. So those 4 numbers, 360 degrees, that's a circle. 180 degrees, that's a straight line. 90 degrees, that's a line that's straight up and down. And 45 degrees, that's half of a 90-degree angle. Great.